Okay, this is our review for section 6.2. Again, chapter 6 is exponents, and now we are working with adding and subtracting polynomials, which simply means we're adding and subtracting different terms that are going to have probably different exponents and maybe different bases. So we have to see what we can and what we can't add or subtract. So the first thing we need to remember is that we need a common base and a common exponent. In other words, even if I say that our second example here, 3x squared plus 3x to the fourth, that's already simplified. I can't add those together. Even though they're both x's, even though the base is the same, if I have an x squared, I can't add that to an x to the fourth. They're not the exact same exponent. So in order to add them, like our first example there, 3x to the third plus 4x to the third, those I can add together. And I get 7x to the third. So what changes is the coefficient. When we do have a common base and a common exponent, if we add them or subtract them, all that's going to change is the coefficient, because what we're changing is the number of them. So for those of you that have had my class, when we take our red marker and our black marker, if we call the black marker x squared and we call the red marker x to the fourth, they're both markers, they're both base x. But if the black marker is x squared and the red marker is x to the fourth, I can't add those two together to get anything. I wouldn't have two of one thing. I still have one of two separate things, right? So again, I can take our first example, 3x's cubed. I can add 4x's cubed, and now I have 7x's cubed. Notice I didn't change the exponent because the item itself, the base and the exponent, that didn't change. The only thing that changed was the number of them. I cannot add x squared or 3x squared plus 3x to the fourth because they're two different things, so I can't add them. The type of problem you'll see from section 6.2 is written out here, and notice the red is what I've done in order to execute the problem. What it originally was is the first parenthesis minus the second parenthesis. And the first thing we need to do is remember that we have to identify the operation. So once I see that I am subtracting this whole first value from this, I'm subtracting the second value from the first value, I'm going to change that middle subtraction to addition, there with my red marker. And then what was a positive 2x to the third became negative. What was a positive 3x squared became negative. What was a minus 4x became plus 4x. And what was a positive 6 became a negative 6. Again, the key issue here, and what was missed most often on the quiz, is identifying that that operation is subtraction, and that in order to subtract that whole second value, I change the subtraction to addition, and when I go to change the sign of the next value, I have to change the sign of every single value inside the parentheses, every single one. In this case, I had to change 4 signs, okay? Then I can see what I can add and subtract. Those dashed lines are just kind of pointing out for us what are the same base and exponent. So for example, 6x to the third plus negative 2x to the third is 4x to the third. Negative 2x squared plus negative 3x squared is negative 5x squared. 3x plus 4x is 7x. And negative 4 plus negative 6 is negative 10. Identify the operation before you try to execute it. A common mistake on the quiz was you saw the parentheses and you assumed it was multiplication. Don't assume. Find the operation and then execute what you can.